Hi guys, this is Mrs. Black and I'm so excited to be doing this video because this is one of my favorite things that we do in Algebra 2. It's 3 systems of equations with 3 unknowns. But before we get into that, I want to look back a little bit at our 2 systems of equations with 2 unknowns. Remember, our unknowns are our variables, x and y. They can stand for numbers, and our puzzle is to figure out what numbers that they do stand for. So if you look at this system of equations right here, how we've got this one placed, how would you solve this one? Now this one, since it has both the x and the y on the same side and the numbers on the other side, the easiest way to solve this one would be by elimination. Because, like I said, it's got the x and the y both on the same side. On this one, you've got an x and the y on the same side, but in the second equation, you already know that x equals 4. And what's the easiest way to solve this one? Well, I wouldn't really need to multiply this one by -2 to eliminate that. The easier way to solve this one would be substitution. So I'd like you to keep that in mind as you go through your 3 systems and 3 unknowns, because I don't want you to do any extra work. So if there's something that's going to be easy, make sure that you're looking for that and trying that first. Then we also need to remind ourselves what the solutions might be to a system of equations. Now remember, the first way, and the way that we often have it, is when x equals a number and then y equals a number. This is again when we only had 2 unknowns, and they made an ordered pair that looked like this. It was a number, comma, and another number. This means it has one solution. And if we were to graph it, it would look something like this. And the point would be there in the middle. The next thing that can happen is when we have infinite solutions. And this happens always when the lines are the same line. That's called coinciding. They are the same line. And the third thing that happens is that we can have no solution. And this is when our lines are parallel. Remember that when you have infinite number of solutions, you get something that looks like the same number equal to the same number. And all your variables are gone. Then on no solution, you get some number equal to a different number, and again all your variables are gone. So on these ones you will still have a variable left. On these ones all of your variables will be gone. Some people get really confused when they have like 15x equals 0 and they think that it is no solution. But if there's still an x there, it's going to be a solution. It's only infinite and no solutions when all your variables have disappeared. So now after that little review, let's get on to what we're doing today. 3 systems, 3 unknowns, one of my favorite things we do in Algebra 2. I'm so excited. So what the solution might look like here is we still can have one solution, but since we have 3 variables, it's going to look like this: x, y, z. It'll have 3 numbers. It'll be a triple pair. You can still have no solution, and you can still have an infinite number of solutions, but remember, for these 2, all the variables will be gone. So let's look at our equations here. We've got x, y, z, and a number on all of these. Notice our x's, our y's, and our z's are all on the same side. So is it going to be easier to do this by elimination or substitution? I hope you're thinking elimination, because that's exactly what it's going to be. Then the second thing we look at is we've figured out that we're going to do this by elimination, so now we need to figure out what we're going to eliminate. Remember, elimination, we need to get one of the variables to have the same number in front of it but opposites. So if I look over here on my x's, x has a 4, a -2, and a 3. Now those are all fairly nice small numbers, except there's no easy way to make -2 become 3, well, there is an easy way to make -2 become the opposite of 4, but there's not an easy way to cancel this one. So let's go on to our y's. Now our y's have some easy numbers. It would be fairly easy, right, to make a -1 cancel a +2, or a -1 cancel a -4. We could multiply this top equation by a couple different things and cancel those, right? So this one would be an easy one to eliminate. Y would be pretty easy to eliminate. But if you look over at Z, we have -z, -z, and +z. Look, all of our coefficients are 1, which means I wouldn't have to multiply these by anything to get the equations, to get the z's to cancel. So what I think I'm going to do is cancel z's, because that looks like the easiest way to do this. So I'm looking at my z's, and I notice that this one's positive and these two are negative. So this one will cancel both of those. So I am going to use Mrs. Miller's vocabulary for this. She chooses a victim, and her victim is going to be the variable that we're going to cancel. So our victim here is going to be z. And then we number our equations. This equation is number 1, this equation is number 2, and this equation is number 3. Now notice I've done these in colors as well, just to give me another way to differentiate them. But if you are doing this all in pencil, having these numbers is going to make this a lot easier for you. So my weapon is going to be the one that I'm going to use to cancel the other two. So since this one is positive and these two are both negative, I know this one will cancel this one, and this positive z will cancel the other negative z as well. So my weapon is going to be equation 1. Now I just need to line them up. So equation 1, and again, this one's an easy one because I don't have to multiply anything because I looked for the easiest variable to cancel. So I've got my 4x minus y plus z equals 14, and then I'm going to use that with, that was equation 1, and I'm going to use that with equation 2. Negative 2x plus 2y minus z equals negative 12. Now the tough part about 3 equations and 3 unknowns is that I always have to be very careful about my math. Any wrong math here will mess up our whole problem. So we have to be very much perfectionists in this. So I always double check, did I write down the equation correctly? Did I bring it down here correctly? And it looks like I did. So I am now going to create equation 4, and I know this is getting a little hectic, but that's why I'm going to use another color. Equation 4 is going to be these two combined with no z's because we're going to cancel them. So 4x minus 2x is 2x, negative y plus 2y is 1y, my z's cancel, and that equals 14 minus 12, which is 2. Now again, like I said, double check your math, make sure you are correct, because any problems here will mess you up forever in the long run. So I made equation 4, now I have to make another equation. Notice equation 4 only has 2 unknowns. Now remember, when we're solving systems of equations, we can only solve for one variable at a time. So what I'm trying to do is go from 3 variables down to 2 variables, and eventually I'll go down to 1 variable and figure out what that number is, then start plugging it in. So my next thing is that I need to grab these 2 equations and get another 2 variable system. So I'm still going to be using equation 1 because that's my weapon, and I'm not multiplying it by anything because I don't need to. My z's are already set up to cancel. And that's just because this one we're starting off with a nice easy one. So equation 1 and equation 3, I bring them down, and I need to number them so you remember where that came from. So this is equation 1 and equation 3. Now, like I said, I'm going to use these to create another equation that has only 2 variables. So here's my new color. This will be equation 5. I hope this pen's going to work for me. 4x plus 3x gives me 7x. Negative y minus 4y is going to give me negative 5y. My z's are going to cancel, and then I have to add 14 plus 27, so that's going to give me 41. Now I need to double check my math. Am I sure I'm correct on all of those? Yes, I am. So this is my 5th equation. Now, since I have 2 equations that have 2 unknowns, I can be done with equations 1, 2, and 3 for just a little bit, and I'm going to focus my attention on equations 4 and 5. Now equations 4 and 5, notice I have my variables on one side and my numbers on the other. So in my opinion, it's still going to be easier to do this by elimination. So I want to notice what we've done. We've formed a new system of equations, and this time, how many variables do we have and how many equations we have? This time we have 2 equations and only 2 variables. So we have a new problem, kind of, in that we now have to take these ones and figure out how we can get our one more variable to cancel. So 2x plus y equals 2, and my other equation was 7x minus 5y equals 41. Come on, pen. Okay, I think I'm going to have to switch to black for this one, sorry. Okay, so if I look at this, 2 and 7, it's not easy to make 2 become 7. 1 and negative 5. Oh, that's going to be pretty easy. I can easily, this is a negative 5, so what would I need here to cancel it? I would need a positive 5. So I can easily multiply equation 4 by 5, and then I will cancel the y's, right? So I'll just move equation 5 over here. 7x minus 5y equals 41 is equation 5. Now equation 4 I need to multiply by 5. So 2 times 5, this is now my 5 times equation 4. That's the new one that's going to come over here. Now don't forget, when you are multiplying, you have to multiply every single thing in there by 5. Don't leave something out, because if you leave something out and don't multiply it by 5, everything will be wrong. So 2 times 5 is 10x. 1 times 5 is 5y, 1y, and 2 times 5 is 10. Again, let's double check. Like I said, every single time you do something, double check, especially double check negatives. That is the thing that tends to mess people up the most. So now we can get this taken care of. Let's see. If we add here, 10x plus 7x is 17x. My y's are gone, and this equals 51. Now notice I am finally to where I can start solving this puzzle. I could figure out what x is. So I need to divide both sides by 17, and x equals, 3. Yay! So I could start my ordered pair. Down here. I know that x is going to be 3. But now I need to find y and z. Well, can I put x back into one of these top equations to find both of them at the same time? No, you know we can't do that. We can't solve for 2 variables at once. So we're going to go kind of back up the ladder. We're going to put it into one of these equations first. My pick is equation 4 because it has the less, it doesn't have anything multiplied by y. So 2 times my x, which is 3, plus y equals 2. 2 times 3 is 6, plus y equals 2. Subtract 6 from both sides, and y equals negative 4. I'm going to put in a negative 4 for y. I need to hurry because I'm almost out of time on this video. So next, we're going to put it into one of these top 3 equations. It doesn't matter which one. I'm going to pick equation 1 just because z is positive in that one. So in equation 1, now I'm going to plug that back in. And I have 4 times x, which was 3, minus y, which is negative 4. So minus negative 4, which becomes actually plus 4. Plus z equals 14. So 4 times 3 is 12, plus 4 plus z equals 14. So 12 plus 4 is 16, plus z equals 14. We subtract 16, and we get z to be negative 2. So z is negative 2, Hooray, we have one solution and we are done. Great job.